Alright, so this is just going to be a quick little tutorial, so this is not one of my lesson videos, so this video should hopefully be less than 10 minutes. So here we go. So first things first, types of equations. So we're going to talk about graph the system of linear inequalities. And basically there's four main types of equations when in Algebra 1 your teacher would throw at you. Okay, so it's just a matter of the combination of the more than one of these together on a graph. What you just basically need to know is how to graph them. And you graph them together, and then you're going to look for where their shading overlaps. So here we go. Types of equations. So you have y equals mx plus b. So your teacher might start off with something relatively simple. They usually do, where it's already in y is less than or greater than form, and you don't really have to do much other than do slope, graph it, and shade the correct region, right? Every teacher pretty much starts off that way. So there's that equation. The next equation is y equals b. So this formula is important because this formula represents a horizontal line. So if you don't have the x variable, you have a horizontal line. The next one is x equals a. So x equals a. So notice mx plus b is for slanted lines, and this is your horizontal line. So therefore, this x equals a. That's your vertical line equation. Okay. So if you have this x is greater than or equal to, a 6 is my example. So that's the example that I'm going to work with to show you today on if I have a system of these things. Okay, so now here we go. Ax plus by equals c, that's standard form. That's the other one. There is one other equation, which is point slope form. I as a math teacher, I don't give that one. And I've really never seen anybody give that one, so I just don't necessarily think that anybody would. I mean, if your teacher throws it at you, okay, let me know, and I'll make a video for you. It's just not something that commonly people throw at you. So these are the four that I'm choosing for this video. So let's get at it. Let's get moving. So first things first, these equations are the easiest because you're just going to graph them as normal. The only thing you need to know is that if it's a less than or a greater than. If it's a less than or a greater than, okay, so if you have y is less than problems, it means you're shading below the line. Okay, so I like to just put little down arrows just to remind me that I'm shading below. But what that will look like is a line, something like that, or like this. But either way, you're going to shade down underneath it. All right, that's the first piece. If it's greater than or equal to, it's the opposite. So which means you'll have your line, you'll just be shading above it. I like to put a little up arrow for reminders. So it doesn't matter what it is, you're just shading above the line. Okay, so that's that little piece. All right. So less than is below the line, greater than is above the line. So that's piece number one. The other second piece is if it's equal to, it's a solid line. If it's a strict less than or a strict greater than, it is a dashed line. And that's it. Those are the pieces you need to know. So let's get at it. Let's get going. So here we go. We have y is less than or equal to 7/3 x minus 4. So all I simply need to do is I'm going to pick two systems. So the two systems I'm going to pick to start off with are just going to be these first two. I'm going to graph them together. Okay. So, and I could put multiple of y equals mx plus b's together. I'll do that last when I use this one and I put this one and this one together, okay? So here we go. First things first, I'm going to go ahead and graph this. So I get my starting point, so y equals mx plus b. B is my y-intercept starting value, so I plot my point. So there's my point plotted, and then I utilize my slope, which is rise over run. So that means I go up 7 to the right 3. So I go up 7, and then I will go to the right 3. So I go up 1, 2, 3, 4, 5, 6, 7. So basically all you need to do is take -4 and add 7 to it. You will get +3, and then you go to the right 3. 1, 2, 3, plot my point. Okay, it is a solid line because it is equal to, so I graph my line. There we go. And the last thing I need to know is that it's a less than, so I will be shading down. Okay, so I go ahead and I take my shader and I go ahead and I shade down below the line here. So now it's a system, which means I'm going to put two things together. The two things I'm going to place together are going to be the second equation of y is less than 2. So now this is a horizontal line. So this is the equation of a horizontal line. Generally speaking, a lot of the times your class teacher forgets this one, neglects it, and then you get on a state test and all of a sudden you get hit with one like this where it's the horizontal line. So you don't want to forget those. You don't want to forget these horizontal line ones. So anyway, a horizontal line, so y, if there's no x, is a horizontal line. It's going through b, so I still have my y-intercept at being 2. So I plot my point of the y-intercept at 2. Okay, and what I'm going to do is draw a horizontal line through there. Now the only thing I'm going to be cognizant of is that that horizontal line, okay, is going to be dashed. So I dash that horizontal line. All right, so there we go, horizontal line going through 2. And now there's a couple things you can do here. All right, you already have one shaded region, okay? The thing you need to know is that you're going to be shading below this dashed line. Well, you only are going to shade in below the dashed line where shading already exists. So I am not going to shade in this region because shading doesn't already exist there. I'm only going to shade, okay, in a region that already has shading. So that's an important kind of idea here. So I'm just going to shade, all right, where shading already exists, because in a system you only want to go where you have a place where a point satisfies both systems. So there is no point in shading over here to the left because there's no answers there already for the first line. So I'm just going to go ahead and shade wherever I already have the dual shading, okay? So basically, then I'm done. There's my answer. So depending on how your teacher likes it, okay, so they want you to maybe darken in that region, so you signify that that in particular is my shaded region, so whatever it is you need to do, whatever your teacher expects, right, if they want it different colors, whatever it may be. Okay, so this region where I've got all this multiple shading occurring, just so you're aware, this is the region right here that I keep shading over and over again where my solutions are. So most of the time, all right, so my students, I make them erase this region that's up here. So, but anyhow, that's there's that, and that's what that is essentially going to be used for, okay? So from here, okay, let's try another example, all right? And the other example we're going to do is I'm now just going to pair together this example with this example, okay? So I'm going to do this one first, okay? It says x is greater than or equal to 6. So now the thing you need to know is that this is your vertical line formula. So I'm going to go to my x-axis. So this has no y-intercept. A vertical line will not have a y-intercept. So I go to where x is 6. It's the only line that I ever plot my first point not on the y-axis. So I go to where x is 6, okay? So I go where x is 6, there we go. And then what I'm going to do is, because it's equal to, I'm going to draw a solid line that goes straight up and down right through there. Now, you need to shade in the way that the x value moves because there is no y-intercept, so this is greater than. So my shading will actually occur, okay, greater than, and this is the only one where you don't think about shading up and down because it's a vertical line, so you need to think about shading left and right. So in this case, x is greater than, and x's are greater to the right of any vertical line. Okay, so there's that vertical line that came through. All right, so there's that. That's the third type of equation. So the last type of equation, just to go through it, is going to be this, these standard form equations. And these standard form equations require you to convert them into y equals mx plus b, because you can't graph them without doing so. So what we're going to do is we're going to go ahead and do that. So to do that, there's a couple things you can do. You can utilize a quick little shortcut. The quick little shortcut is, okay, y is equivalent to the opposite of a divided by b times x plus c divided by b. So that is a quick little formula, and that basically, that quick little formula comes from rearranging the standard form as a literal equation. Now, a literal equation just means you take the formula and rearrange it for the variable you want, and that will create you a new formula, okay? So in this case, I could use that, or, okay, I could simply use properties of equality. So basically what that states is, if I want to get rid of 3x to get y by itself, I use the addition of opposites. So this is a positive 3, so I go minus 3x, I get negative 6y is greater than negative 3x plus 18, and the last step here is to divide by negative 6, divide by negative 6, divide by negative 6. So now I just want to point out to you very quickly here. Okay, if you take a look at this, okay, this formula, just to show you, this negative 3 is the opposite of 3, so utilizing that formula, right? The b is negative 6, so I'm just dividing by negative 6, right? And the c is the same thing as normal, just dividing by the negative 6. So right here, you can see how that formula does come true, because to solve these, you do literally the same step every time. Now, the only thing that I want you to be cognizant of, is very, very cognizant, very, very important, okay, is if you divide an inequality by a negative, you must flip that inequality. Now, I have a lesson tutorial on this, and you just need to watch the first like 8 minutes to understand this. So if you want to, go to my YouTube, and you go to my YouTube channel, MingerD1 YouTube, and just check it out. It's a quick little 8 minutes, and it will explain why you need to flip that inequality. It's a pretty logical thing. But anyhow, here we go. So I get, simplifying this equation, I get 1/2 x minus 3. Okay, so then last thing I do, I just got to go graph it. So here we go. I go to -3, and then this time, and then I'm going to plot my points, and I go up 1/2, plot my point, up 1/2, plot my point. I've got all I need, draw my line through. Okay, and now when I draw my line through, again, when I do my shading, I'm going to shade below this line, but I'm only going to shade in a region that currently has shading that my line, okay, the shading would be below. So in this case, I go here, and my shading will happen right here. So this is where I overlap my shading, okay, and my final answer will be this particular region right here. All right, so this region right here, this is my region. So I'm trying to make this region as dark as possible here, so just to show that. All right, so here we go, making this region that I'm blackening in here. That right there is my final answer. Now, most teachers will take that, even with this particular shading up here, most teachers will take that one, even with leaving that shading on there. Technically speaking, you really shouldn't leave that shading there. You should erase it. But if you notice, I do now have my final solution. It's now graphed. Okay, so I hope that helps. And I hope you're starting to understand this a little bit more. So yeah, so let's continue at this and do one last one. So the last thing we're going to do is we're going to combine the two y equals mx plus b with the standard form. All right, so your teacher will throw at you any version of these, but the last thing I'm now going to do is going to combine the first equation with the last equation. We already solved the last equation. We get y. All right, we found out we got less than 1/2 x, okay, minus 3. So what I'm going to do is I'm just going to graph both of those on a graph to show you what a lot of your equations, your teacher will give you two of these, that you have two lines that are indeed slanted lines, and they do have some sort of a gradient to them, or a rate of change to them. So here we go. So we're going to plot them one at a time. So what I highly suggest is graphing them one at a time. So here we go. Get the first one. So -4. So we have, plotting my first point, starting point is at -4. I go up 7/3, so this should look familiar. I already have that. I'm going to connect those with a solid line. I only need 2 points for these as well. And then I'm going to go ahead and I'm going to shade below the line. So I'm going to go ahead and, here we go, shading below that line. So there we go. And the next thing I'm going to do is I'm going to go ahead and I'm going to plot the other line. So when I plot the other line, I'm going to use a different color. So I plot the other line, I go to -3, so here we go, -3, plot that point, and then I'm going to go up 1/2, up 1/2, I have enough, got everything I need there, draw my line through. All right, so now this line is telling me to, oh, sorry, I made a mistake there, right? That line that I just drew should have been dashed. All right, so easy to make that mistake, but don't make that mistake. Why is this one dashed? This one's dashed because it's not equal to. The first one was equal to, so I drew a solid line. So anyhow, the last thing here before I finish up this video is just to simply remind yourself that you are only going to shade. So this line, all right, this line right here is telling me that I need to shade down. So I'm only going to shade below that line where a shaded region already exists, because in a system you are looking for answers that satisfy both solutions. So I already have solutions to the first line, so I only want to overlap current solutions, right? Because I want dual solutions. So I'm going to go ahead and I'm going to shade below the line. Right here we go, in this region right here where I already have shading exists, and then I'm done. That's it. Okay, so that's how you graph systems of equations, technically speaking. Okay, if you had me, you'd have to do that right there. All right, my kids, I make them erase that shading. But hey, ask your teacher, see what they want, see what they prefer. But all I'm going to say is that this is your final answer. So this was just a little quick hitter. If you're looking for something a little bit more, I got a video that's about 36 minutes long, so check out my channel. All right.